Okay, 2.2 day 4, we're doing quadratic applications, which means modeling, which means word problems. Okay, let's look at the first example. It says a fireworks rocket is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height, measured in feet. The height of the rocket as a function of time in seconds can be modeled by the function f of t equals negative 16t squared plus 64t plus 80. So that's my function. Okay, let's read this. What is the y-intercept and what does it represent in this model? Okay, well, the y-intercept is the c value, which is 80. So I'm going to list what it is, and then we'll go back and read what it represents. Okay, so a fireworks rocket is launched from a hill above the lake. The rocket will fall into the lake after exploding at its maximum height. Okay, let's look at this for a second. Okay, since the equation is quadratic, it has a squared, it's going to make a parabola. Since it's a negative, it's going to open in the downward direction. This is what I'm thinking about while I do it. At some point, they're telling me it's going to explode at the maximum height. When they say maximum height, they mean that point, which is vertex. So they're talking about the vertex. It's going to explode at the vertex. The height of the rocket is a function of time, t, in seconds can be modeled by the function f of t equals this equation. So if this is my y-intercept, that's saying at t equals 0, this is 80 with the units for the f of t, they're feet. So at times 0, this is 80 feet. 80 feet what? Let's read it again. Okay, a fireworks rocket is launched from a hill above a lake. So it starts out on a hill above a lake. So at time 0, it's 80 feet high. Why is it 80 feet high? Because that's how tall the hill is. So hill is 80 feet tall, because that's when I launched the rocket from the hill. Okay, part B, find the maximum height of the rocket. Now, when they say height, they're referring to the vertex right here. Okay, so I'm going to find the vertex. What's the formula for vertex? Oh, it's h equals negative b over 2a. Okay, let's start by doing that, and then we'll think about if we've actually solved it. So h equals negative b divided by 2 times a. Is that 2? That's 2. Okay, now h is the x-coordinate. The x's are what? They're t's, and t is represented in seconds. So this is saying 2 seconds. Okay, and you do want to think about it as you go, because if I had gotten a negative answer here, that wouldn't have made sense because we can't go back in time. So is it asking me how many seconds? No, it's asking for the maximum height. So at 2 seconds, I need the maximum height. So I'm going to go ahead and plug this back in to the height of the function. Okay, and if you want to use a calculator for these, you're welcome to, but still follow your order of operations. 2 squared is 4. Okay, what is that? 64 plus 80, so 144. So at 2 seconds, this is 144 what? Feet. So the max height is 144 feet. Okay, now it says sketch the graph, label the y-intercept and maximum point. Okay, this sounds weird, but we can just sketch this. Okay, where does this start from? It starts from 0, 80. So let's sketch a little graph. So 0, 80 is somewhere here. It's a sketch, so I'm just going to label 0, 80. So that's my y-intercept. Okay, where's the maximum point? We found it here. It went 2 seconds, 144. So 2, 144. Okay, I don't know where that is exactly, so I'm just going to make a sketch. 2, 144. Okay, since there's no scale, I'm going to label it. Okay, I'm going to sketch the graph. So what happens is fireworks starts here. They launch it in the air. And then supposedly it explodes at its maximum height. So it should be exploding way up here. See, look, fireworks. Fun. Okay, but, and then its casing is going to fall down. And that's the path of the fireworks. Okay, if you're confident, you can try the practice problems on your own. If not, we will go over them. So it says a ball is thrown upward from the top of a 128 feet building with an initial speed of 32 feet per second. The height of the ball is a function of time. So the height of the ball as a function of time can be modeled by this equation. Let me look at the equation, that's important. Sketch the graph and label the y-intercept and maximum height. Okay, let me start sketching the graph now. Okay, what's the y-intercept? It's our C value. What's C? C is 128, so I'm just going to start it right there. 0, 128. Okay, then I'm going to actually do the calculations, but I'm going to read it again. So the ball is thrown upward from the top of a 128 feet building. That's why it starts here. This is the top of the building. They throw the ball up, and then it's going to come back down somewhere. Okay, let me go ahead and I'm going to sketch the path, even though I don't know exactly what to do. So the ball goes up, hits the ground. I don't know what it does after that. Crashes, bounces, whatever. Okay, so I sketched the graph. I labeled the y-intercept. I didn't find the maximum height. Whenever I see a maximum, they're referring to this point, which is the vertex. Okay, so vertex. H equals negative b over 2a. So I get positive 1. This is my x-coordinate, which is really my t-coordinate, and t represents time. What are the units for time? Seconds. So I want the maximum height. This is not the maximum height. This is the time when I get to the maximum height. But I know this is going to be 1 comma something. So let me fill that in. Okay, I want the maximum height. So let's plug 1 back in. Negative 16 times 1 is negative 16. Okay, what is this? This is 16 plus 128, which is 144. And what are the units on the height? Feet. Okay, so this is 1 comma 144. So let me read the question again and make sure I answered it. Okay, sketch the graph, label the y-intercept. Okay, the maximum height, 144. What is the maximum height? Oh, well, the maximum height is 144 feet. Okay, again, if you're comfortable, keep going on it. Unpause if you want to see the answer, fast forward it. Okay, a ball is thrown from ground level upward at initial velocity of 60 feet per second. The equation for the projectile motion is P of t equals negative 16t squared plus 64t. What is the ball's maximum altitude? Sketch a graph, label the y-intercept and vertex. Okay, I'm going to just do the graph because I can think about this. Okay, what's the y-intercept? It's the c value. What is there? There's no c value, which means what number is the c value? 0. So this thing's going to start from 0, 0. Okay, let me read it to make sure that makes sense. The ball is thrown from ground level. So it starts from the ground, which is why it's 0, 0. Motion goes like this, and then it's going to come back down. So I'm going to sketch it, even though I don't have the exact height of it. Okay. They still want the maximum altitude. When I see maximum, I'm thinking vertex. And I also need the vertex for the graph. Okay, so h equals negative b over 2a. If you're like, why is it always negative 16? It's because of the Earth's gravity. So we're on Earth. That's often what it is. Okay, anyways, this is the x-coordinate, but in this case, x is t, so t is time. Do we have units for time? We do, it's seconds, so at 2 seconds. This point is 2 comma something. Maximum altitude, let's plug this back in. What is this called? P of 2. Okay, that is 64. So the maximum altitude is 64 watts feet. Okay, let me label my point here too. Okay, so let me make sure I answered the question. What is the ball's maximum altitude? Got it. sketch the graph, label the y-intercept and the vertex. Okay, go ahead and try 3. Okay, a ball is thrown upward from the surface of Mars with an initial velocity of 60. The equation for the distance from the ball from the surface of Mars is negative 5t squared plus 60t. Find the maximum distance between the ball and the surface of Mars. Sketch a graph with the y-intercept and maximum point. I'm going to do the graph because it helps me understand the question. Okay, the y-intercept, A, B, no C. C equals 0. 0, 0. Okay, does this make sense? Okay, the ball is thrown upward from the surface of Mars. So it starts on the ground of Mars, goes up, comes back down. Okay, find the maximum distance between the ball and the surface of Mars, which is still vertex. Okay, let's try this. H equals negative B over 2A. Okay, and if you're wondering what happened to the 16, it's because we're on Mars and the gravity on Mars is different. Okay, H is the x coordinate, which is really the t coordinate, so this is the time. So this is 6 seconds. So 6 comma, we need the maximum point, so we need to plug this back in. So the distance at 6 seconds what is that, 360? Okay, and if you need a calculator, go ahead and use a calculator. I think that's negative 180. So I get 180. So what's the answer? Maximum distance. So the maximum distance is 180 watts feet. Okay, and then let me label my ordered pair and let me double check that I did everything. Okay, find the maximum distance. Got it. Sketch a graph. Got it. Y-intercept, yes. Maximum point, yes. Let's do the last one. And if you're ahead, that's okay. Okay, a rock is thrown upward from the top of a tower. The height of the rock above the ground as a function of time in seconds can be represented by the equation h of t equals negative 16 times t plus 1 times t minus 9. Okay, sketch a graph labeling, twist, the x-intercepts and the vertex. How long does it take for the rock to meet its maximum height? What is the rock's maximum height? Let's start with the graph. Okay, now the weird thing is they want me to do the x-intercepts. So let's look at this. Why do they want me to find the x-intercepts? Oh, because it's in factored form. Factored form makes it easier to find the x-intercepts. The x's are actually the t's, so I'm solving for t. So if I solve this, what are my x-intercepts? I would get t equals negative 1 and t equals 9. So negative 1, 0, and 9, 0. Oh, let me make my graph a little bit longer. Okay, I'm going to label negative 1, 0, and I'm estimating, so I'm just going to label them. If I had a grid, I would just use the grid. Okay, now I need the vertex. Okay, how do I find the vertex with factored form? I need to find in the middle of the two. So I'm going to do negative 1 plus 9 divided by 2. 8 divided by 2 is 4. And this is the x's, which is the t. So what are the units on this? Seconds. Okay, so at 4 seconds, it's going to reach its maximum height, which looks reasonable. Okay, let me go ahead and sketch it even though I don't have all the information. And then we'll go back and review it. Okay, now I need the y-coordinate, so h of 4. Okay, it's in factored form, which is intimidating, which is normally not terrible. So this is negative 16 times 5 times negative 5. And you can put the whole thing in your calculator, or you can do it piece by piece. It doesn't make a difference. And what is that next? 16 times negative 20. It's going to be positive for sure. So 16 times 25, I think, is 400. 400 watts. The height is, oh, it doesn't tell me the unit, so we're just going to call it 400. Okay, let's go back and read the question to see if we answered it. Okay, a rock is thrown upward from the top of a tower. Let's look at our graph. Now here's the weird thing. If it's thrown from the top of the tower, it's probably actually thrown from here, which means that on the left, that's not really part of the graph. I don't mind you having it there, but to show that it's not really, I think I'm going to dash it. Oh, that was a terrible dash. Let me retry. Okay. I'm dashing it because it doesn't technically launch at -1, time is -1, because that doesn't make sense. It has to start at time is 0. So it launches and it goes this way. If you include this, it's fine. It doesn't bother because it said to label it on the graph. Okay, the height of the rock is modeled by this. Sketch a graph labeling the x-intercepts and the vertex. Got it. How long does it take for the rock to reach its maximum height? Oh, that should be seconds. So after 4 seconds, it reaches its maximum height. What's the rock's maximum height? Max height is 400, and it didn't tell me the units, so you can say 400 units, or you can just say 400.